Hello everyone. It's another episode of 5 minutes with Simply Data. So far, we have discussed about network, security, and performance monitoring use cases, but we have not touched about operations. A matured operations center incorporates automation into its workflow. Today, we will discuss and demonstrate the top automation use case that we are using in our operations center. As usual, if you do have further questions, just leave those in the comment or PM me directly on LinkedIn. I'm Eric, your host for today. Before diving into the demo, allow me to give some background on what we are trying to automate. We are managing the entire network infrastructure for some of our customers. For these customers, some of their branches are located in remote locations where there are power supply and WAN connectivity challenges. The problem is that whenever device offline alert is triggered in our network operations center, we do not know immediately whether it is ISP outage or power outage, ISP being the internet service provider. Our engineers have to manually ping and trace route to pinpoint the exact root cause. While this is not a complex troubleshooting step, it is something that is very tedious. Imagine if you have hundreds of device alerts every single day. How much time do the operations engineers spend time doing ping and trace route? Time could have spent on doing something more productive. Does the engineer get job satisfaction from doing all these mundane tasks? So these are the common questions that a operation leader ponders on a daily basis. In our simulated lab environment, we are using FortiGate firewall to simulate the ISP. We have modified the automation script a little to fit into this demo video. Alright, so enough of talking and let's go into the demo. This is our probe, and we can see that this is configured with the IP address of 10.2.0.5. Let's launch the demo script. The script will first do a basic sanity test just for this demo. Based on this test, we can see in dashboard that ping to 10.0.0.12 is successful. From the ping result, we can derive its jitter, round trip time, and packet loss. On the right hand side of the screen, we can also see its trace route results. As you can see over here, the probe needs to go through one hop, which is 10.2.0.254 before reaching to the remote branch device. Now, everything is working fine and everyone's happy. Let's create issues in the network. So we will create firewall policy to block connectivity between probe and remote branch device. This is to simulate ISP outage. With this in effect, later in the trace route result, you will be able to see that 10.2.0.254 is not reachable. All the keep alive timers in this demo are the same as our production environment, meaning every 30 seconds there will be multiple SNMP and ping attempts from probe to the remote devices. If it fails for 3 consecutive times, then alert will be triggered. When alert is triggered, the automated troubleshooting script will also be triggered. Also, take note, since trace route will fail, the automated troubleshooting script will run for quite some time before officially stop due to timeout. So instead of waiting silently for 2 minutes, let's fast forward the video a little bit. Here you can see that email notification has been sent at 12:50 PM. So alert has been raised and automated troubleshooting script is triggered. At this time, our engineers are making coffee or maybe some tea. So fast forward again until the automated troubleshooting script times out. As you can see over here, in about 2 or 3 minutes after alert notification is sent, the script execution is completed. Here, the result states that 10.0.0.12, which is the remote branch device, is not reachable, and the trace route fails in the first hop, which means it is the ISP router. For this particular case, we can conclude that this alert is triggered because of ISP outage. Our engineer will then proceed to escalate to the internet service provider. From estimation, it saves our engineer 45 minutes per day per engineer for this one troubleshooting use case. In other words, it increases our engineer's efficiency by 10%. Simple automation, but powerful results. So that's the end of today's episode. Thank you all for listening. Don't forget to like, and if you're on YouTube, subscribe to our channel. Gerak dulu guys, bye.